Okay, so I just wanted to talk a little bit about our fourth way of solving, which is the quadratic formula. So just as a reminder, there's 4 ways to solve quadratics. So far we've graphed, we factored, we completed the square, and now we're going to look at the quadratic formula. So I know from talking to you guys that you've seen the quadratic formula. It's part of really every algebra class, so I'm sure you've used it before. If you don't have it memorized, you'll definitely want to get there. Next time I see you, we'll actually see where this comes from. So right now I'm just kind of writing it there. It's like magically appearing. And next time I see you, we'll kind of actually derive that so you can see where it's coming from, not just some random formula that we have. So just a few quick things. Most people have trouble right here with this minus 4ac part. So please just be really careful with your signs. Whether you treat this kind of as subtraction and multiply 4ac and then subtract, or whether you think of this as negative 4 when you multiply, just be really careful in that spot right there. That's what gets a lot of people. So I'm just going to look a little bit about solving here. So personally, my preference whenever I'm solving is to see if I can factor first. I'm just comfortable with that. It to me is the fastest way of solving. This one can't be factored, so I'm just throwing that out there, that I like to factor first if I can. And I also don't think this is a really good candidate to complete the square because it has a leading coefficient. So we can factor it out, we can solve, we've done it several times where we factor out that 4 first. It's just not my preference either. It's not the best candidate. So let's go ahead and use the quadratic formula. So keep in mind here's our a, b, and our c value. And also notice that this is set equal to 0. We're still looking for zeros where the graph crosses the x-axis. So you definitely want to make sure that it's equal to 0 before you go. So it looks like we're going to have the opposite of b, so negative 3, and then plus or minus our b squared, and then minus 4 times a, which is 4, and c, which is 2, and then all over 2 times 4. Okay, so we'll just go from there. So negative 3 plus or minus the square root of 9, 16 times 2, so minus 32 over 8. So it looks like we have the square root of negative 23 over 8. Okay, we're not done. I just want to point out right now that we have a negative under the square root, so that tells us we're going to have imaginary solutions. And if we have imaginary solutions, then our graph is not crossing the x-axis. So right here, just kind of knowing this number right here, I know that we're going to have a graph that doesn't cross the x-axis. We're going to have imaginary solutions. And we have 2 of them. We've got that plus or minus there. Okay, so I'm going to go ahead and simplify that out. So this becomes I root 23. Square root of 23 can't be simplified, but we can pull out that negative 1. So this is really this right here. Okay, so I always like to look and see, like, if I ignore the square root. So if you can imagine, I want to like put my finger over the square root. So if I ignore the square root, I've got a 3, I've got a 1, and an 8. And I'd like to see, can all 3 of those things be simplified by the same thing? Can they all be divided by the same number? And they can't. And so here's our final answer here. You might see it written like this. So here they're sharing the common denominator. Here we've just kind of separated them out. Same answers. So we've got 2 imaginary answers here to this quadratic. So maybe I want to say easy as that, but maybe that's not easy, so I should be careful saying that. Okay, let me try one more here. Okay, so notice on this one that it's not set equal to 0 to start, and we want to find zeros, so setting it equal to 0 is really the way to go. So I'm going to go ahead and subtract 12x. And I'm going to put it in standard form as I went, so here's my A, my B, and my C. So using the quadratic formula, opposite B times B squared minus 4 times A times C and then all over 2 times 1. I should have pointed out at the beginning, by the way, this one actually is a really good candidate for both factoring or completing the square. We've got a nice even number here and nothing out here. So while I'm choosing to use the quadratic formula, I actually really think one of the other options might be just as good. But that's the nice thing. We'll get the same answer either way. So here's 144, and 4 times 36, that's 144 also over 2. So I wanted to show this one because of this right here. So we end up getting a 0 under the square root. And so when we do this, we're going to take 12 plus 0 and 12 minus 0. That's really the same number. And so here we're only getting one answer. And so I wanted to think about what does that mean for the graph. So we're left with just x equals 6. And we know when we only get one solution, that means the vertex of this graph is on the x-axis. So this one's really kind of only hitting the x-axis once. If you remember, this is kind of that multiplicity. We got the same solution 2 times. But it all kind of comes back to the fact that we have a square root of 0 right there. Okay, well, we've done an imaginary one. We did one with one solution, so I feel like we might as well do one that is going to have 2 real solutions. So here's the equation. Okay, again, if I'm thinking about factoring, I can tell it's not going to factor very well. I've only got 2 and 1, and I'm trying to get 4. It actually would be a good candidate to complete the square. We've got an even number here and a no leading coefficient. So it would be a good candidate to complete the square also. But we're quadratic formulaing, so I'm going to go ahead and do that. So opposite b plus or minus square root of b squared minus 4 times a times c all over 2. 2 times a, 2 times 1 in this case. So 4 plus or minus negative 4 squared is positive 16, and then minus 8 over 2. Okay, so I got a positive number here, so that means we have real solutions. So the graph will cross the x-axis twice. So we can simplify this down. So I just made 8 2 root 2. And now, same thing, thinking about simplifying, not looking at the root, but these 3 numbers, if they can all be divided by the same thing, then I'm going to divide them all. So these can all be divided by 2, so we're going to get 2 plus or minus 1 root 2 over 1, which we would really just write as 2 plus or minus root 2. So here's our final answer. So our graph would cross the x-axis in 2 places, 2 plus root 2 and 2 minus root 2. So I'm sure this was a review for you. Hopefully you look at it, you're like, yep, I'm going to be good to go to use the quadratic formula. Again, next time I see you, we will derive the quadratic formula, so you'll see where it's coming from, so that'll be exciting. Hey, good luck reviewing today and thinking about imaginary numbers, and I will see you on Friday.